Hi everyone, this is yours truly, Lady Emmanuel, back with part one of stretching and the quadratic parent function. I would tell you I would not necessarily say this word. I would say compression because SHR words I struggle with saying those, which is okay. Look, I know I'm not perfect. No one is perfect, but it's okay. Hey. That feels good to say that, okay? So here it says graph vertical stretches and compressions of the quadratic parent function. Remember, I don't say this word well. Identify and distinguish among transformation. So we're going to look at, and when it's saying vertical stretches, this is in compressions. Vertical is talking about in reference to the y-axis. Okay. It's talking in reference to the y-axis. If it was horizontal, it'd be in reference to the x-axis. And we're going to identify and distinguish amongst the transformation. You're going to tell what's going on, what is happening. For instance, look, we know the parent function by heart. Now for quadratic function, we know this is the lovely parent function. So we could tell you a lot about it. We're like, okay, we know when it's -2, we know all the y values is going to be positive. So this is going to be 4, 1, 0, 1, 4. We know it's open upward. We know the domain is our real number. The range is y is greater than equals to 0 because we know that, because we covered that. And we're remembering our information because we got it like that. I'm sort of getting pumped. Okay, calm down. Okay. So here we go, babies. Where's my gray highlighter? Anyway, so here we go. Let's go ahead and do this lovely orange for here. Here it says 2x squared. So now notice this. Here is the lovely x squared, the parent function, right? G of x is 2x squared. So this right here is the parent function being multiplied by a factor 2. Well, here we go. So that means that all I have to do is double the y values for the parent function. Isn't that cool? So 2 times this, I'm going to say 8, 1, 0, 1, 1. Look, guys, really? You going to let me put 1? Now, if I double 1 and get 1, it's something that's not right. Okay? So it's 2 times 1, baby. That's going to be 2. Guys. Okay, and you double the 1, you get 1? No, 2. Double 4, you get 8. Here we go. So we got our products. So hey, here we go. Let's do this. On part A, they were nice to us. They said the graph of f of x equals x squared is shown below. They put the parent function there for us. So let's do something to make ourselves feel good. Let's go ahead and highlight it with something. Give it a little color. Color coding it. Oh, thanks to one of my students who like to annotate with different colors. That makes me feel good. So we got our parent function. They go our vertex, our minimum. It said graph g of x equals 2x squared on the same coordinate grid. This helps you to, it helps you to observe the difference and notice the sign of a graph. So we're doing here, -2 is going to be 8. -2 go up to 8. That's -2, 8. -1, 2, -1, 2. We got 0, 0. Oh, they have the same vertex, the same minimum. So that means the range is going to be the same. So then we have here 1 is 2. 1 is 2. 1 is 2. That doesn't sound right. We have 2 is 8. 2 go up to 8. Bam. Right here, let's go ahead and connect this. Sketch. Ooh, I know you guys are going to do a better job than your lovely teacher because you guys are very artistic. Okay, there we go. Let me get the highlighter, orange highlighter, and try to make it look a little cute. Ooh, same vertex. Bring it on up. It lost a little weight there. So here we go. It's a vertical stretch because it's being pulled towards the y-axis. It's like it's pulling it towards the y-axis and it's getting slimmer, okay? If it was compression, it'll be pushed down. It'll be pressed down. It'll be pulling it downward. That's sort of, I don't know. It's sort of like confusing. It's like, I don't know. It's sort of get confusing, but just do it. It's a vertical stretch of a factor of 2, okay? But you'll see, it's not, it'll go further away when it's a string, but when it's a stretch, it comes closer. Okay, but check me. I always verify. Okay, there's nothing wrong with that. Okay, so we did that. Now it's told us part B is identify the vertex, domain, range, and excess symmetry for each function. So now the thing is, the vertex, we see it's a minimum. The vertex is a minimum. So we know that here is 0, 0, because that's the vertex here. Ooh, I thought that was my pink one. 0, 0. Cool. So now I know my excess symmetry. Remember, it's the lovely x value of the vertex. So the x value for both vertexes is 0 because they have a common vertex. Okay? It didn't shift. It wasn't a translation. It didn't shift up, nor did it shift down. It didn't shift left, nor did it shift to the right. Okay? So here it's going to be 0, 0 for our x. Excess symmetry, which is the x value of the vertex. The range, both of them open up, which, so it's going to be y is greater than equals to, y is greater than equals to. The range and the y value helps us with the range. That's the lowest point, or it's the lowest point in this case because it's a minimum. So it's y is greater than equals to 0. And domain for quadratic, guys, what is it? What is it? All right, that's it. All real numbers. Okay, all real numbers. The domain is all real numbers. Good for you. So I'm going to go to the next page, number 2. You're doing the same thing. What I want you to think about it when you do this, because you're going to do this part, think about half. It's a half of x squared, so you take a half of the value of the y value for the parent function. Then when you graph it here, compare it. Look at this says 1/2. What happened to the graph? This says 2 for the factor. What happened to the graph? It says 2. So what happened? So love you guys. Peace out. Appreciate you so much.